Hello guys, today we are going to look at the TCP IP networking model. So here you see the networking model is sometimes also called either a networking architecture or a network blueprint. So you can think of a networking model of like an architecture, like just think of you are building a house. So when you build a house, you need to have a blueprint. So the blueprint can ensure that the house has the right foundation, the structure, it is not going to fall down. It has the current hidden spaces to accommodate the plumbing, electrical, gas, everything, sort of everything. So many people, there'll be many people who will be contributing to build the house using the blueprint. So like electricians, bricklayers, painters, everyone will contribute in order to make sure the house is built. Similarly, when you build up a network, you have to write your own stuff. So you can write your own software. You need to have your own networking cards. You need to create your own network. You need to do a design, engineering design of your own network. However, like it is easier like when you have use products that you know well. You know, have a blueprint of a well-known or networking model so that you can easily use it. So coming back to the history of this TCP IP. So today this world is full of computer networking. They use one networking model, so the TCP IP. However, like with this the world has always been so simple. Like once upon a time, when you see that the networking protocols didn't exist, including this TCP IP. So vendors created the first networking protocol. These protocols supported only the vendor equipment. So example, if you can see the IBM, the IBM computer company was the largest. They had the largest share in many markets since 1970s to 1980s. They had their own system network architecture networking model in 1974. So other models, as a result, like if your company brought computers from these type of vendors, network engineers often had to create the three different networks based on the networking models which has been designed by each company. Then somehow those networks, like making the combined networks much, it becomes more complex. So this is just shows like how a network company enterprise may look. So in the 1980s, so before TCP IP became common in the enterprise networks. So although vendor defined proprietary networking models often worked well, having an open vendor networking model would and competition reduce complexity. So there's something called the ISO, the International Organization for Standardization. So they took a task in the early 1970s, so that they had a noble goal, so that the OSI model to be standardized, having networking protocols to allow communication among all computers across the entire planet. So a second less formal effort to create an open vendor neutral public networking model was devised by the US Department of Defense. So they came up with resulting in an open networking model which is called the TCP IP. So in the 1990s, you see there's only three companies here in the 80s, IBM, these are the vendors. So then they, in the 1990s, the companies began adding the OSI, the TCP IP, or both to the enterprise networks. So the how, like by the end of 1990s, companies began adding OSI and the TCP IP. So TCP IP became the common choice and OSI fell away. So that's where like so in the 21st century, like the TCP IP dominates. So proprietary networking models still exist, but they have mostly been discarded in the favor of TCP IP. So the OSI model, whose development suffered part because of a slower formal standardization process as compared with the TCP IP never succeeded in the marketplace, and the TCP IP network model, originally created almost entirely by a bunch of volunteers, has become the most prolific network right now. So coming to the overview of the TCP IP model, so if you see the TCP IP model over here, to define this protocol, they use they already had some defined protocols. So they, for the TCP IP model, they used a set of rules that allows us to take a computer or a mobile device out of the box, plug in all the right cables, turn it on, and connect it using the network. You can use a web browser to connect to your favorite website. You can use most any app, anything. Well, the OS on the computer implements part of the TCP IP model. So the Ethernet card, the wireless LAN card built on the computer organization, LAN standard elements, they all reference to the TCP IP model. So to help people understand a networking model, the each model breaks the function into a small number of categories. So they call it as layers. So each layer includes protocols and standards related to it. So the TCP IP model shows the common terms and layers used when people talk about TCP IP today. So the bottom layer focuses, if you see the bottom layer focuses on how to transmit bits over each individual link. The data link layer focuses on sending data over one type of physical link. For instance, networks using different data link protocols, Ethernet, LANs, or wireless LAN. So the network layer focuses on delivering data of the entire path from the original sending computer to the final destination computer. And the top two layers focus more on the application needs, like the transport, and the application layer focus more on the application that needs to send and receive different data. So a slightly different four-layer original version of TCP model exists in the RFC 1122, but for the purpose of both real networking and the five-layer model came up. So most of you, like for this TCP IP protocols example, most of the protocols and standard will already explained. So you see here the TCP IP architecture. So in the application layer, the protocols are HTTP, POP3, SMTP. So in the transport layer, the TCP and UDP, and in the internet, it's IP and ICMP. The data link and physical, it is Ethernet 802.11, and that's Wi-Fi. So the TCP IP application layer protocol provides the services to the application software running on a computer. So the application layer does not define the application itself, but it defines services the applications are needed. For example, the application protocol like HTTP defines how the web browsers can pull the content of a web page from a web server. In short, like you can say that the application layer provides an interface between the software running like on a computer and the network itself. So you can say that the most TCP IP applications today is a web browser. Many major software vendors like also like they start a web browser on a computer. You see when you open up, you can type HTTP like that. So what happens really happens to allow that web page on your web browser. So just for an example, we are taking two persons. You can take as like Nob, Dob, or Bob, like any guys. There you have two guys over here. So imagine like this guy over here opens his browser, and in his browser he has configured to automatically ask for the web server of this guy. Yeah, okay. So on the home page, so the general logic looks like so what really happens is like this guy makes an initial request asking for this guy to send his home page back to him. So here so Larry's web server software has been configured to know that the default web page is contained in a file. So this guy receives the file from him and displays the contents of the file in the other one. So how the HTTP protocol mechanism works, so if we take a closer look, the example shows like the application on each endpoint computers, specifically if you say the server and the server away returning the content of this file, the overall logic matches what's happening over here. For the if you see more on this one, like the how the HTTP to get this web page from this that this guy web server Larry into Bob's. Like the Bob sends a message with HTTP header. He sends a message with a HTTP header. So he includes the request to get a file. So he wants to get a type of file. This request typically contains the name of the file. So what type of file? Home.html. So what is the type of file name? So if no file name is mentioned, the web server assumes that he wants to go to the direct the main homepage of the file. So what happens in step 2 is like in the step 2, he makes the response from the web server Larry. He gives him back a response. So the message begins with the HTTP. Again, the message comes up with the HTTP header, and the message says something like okay, return to the header. HTTP also defines the to return the code so that the server can tell the browser whether the request to work. If it doesn't work, you get like HTTP 404. If you have seen, like if the internet does web browser doesn't work, you will get like, or the internet is not working, you get HTTP 404, which is not found. So when like with this server 11, Larry sends to the web browser Bob, this time without a HTTP header. So what happens is like the HTTP transfers the data by sending multiple messages each with a part of the file. So coming back to the TCP IP transport layer, so many TCP IP application layer protocols exist. So the TCP IP protocol layer includes a small number of protocols. The two commonly used transport layer protocols are the transmission control protocol and the user datagram protocol. So the transport layer protocol provides services to the application layer protocols that resides one layer higher in the TCP IP model. So how does a transport layer protocol provide a service to a high layer protocol? So like so what are the TCP error recovery basics? So let's see like what are the type of in a sequence, like how the TCP IP is being sent. So how a web servers it sends the TCP IP in a sequence as a sequence 1, 2, 3. It sends HTTP okay. The data web page says okay, and the sequence 2 says again sends the data. The sequence C is the rest of the web page. The sequence 3 again it sends. So this how like the architecture is. And so coming back to the TCP IP network layer, so the application layer includes many protocols. So the transport layer includes fewer protocols. So most notably, you can say that TCP and the UDP. The TCP IP network layer, it will include a small number of protocols. So IP provides several features, like this IP addressing and routing. Yeah? So it is it is the main topic, like how in which like the computers can communicate with each other. So the internet protocol, and you can coming back to the internet protocol on the postal service. So imagine like that you wrote two letters, one to a friend on the other side of a country and one to a friend on the other side of the town. So you address the envelopes and put on the stamp. So both are ready to go to the postal. So you one to a local and another to another country. So you wrote the letters and you are ready to send the letters. So the postal server, however, must the postal service when it comes, however, must think that each letter separated must take the each letter separately and make a decision where to send that letter so it is delivered. For the letter to send across the town, so when whether it needs to go to the town, the people in the local post office probably just need to put the letter on another truck. For the letter that needs to go across to the country, the postal service sends the letter to another post office. So he needs to send it to another post office and then another, and so on, until the letter gets delivered across the country. At each post office, the postal service must process the letter and choose whether to send it next. To make it all work, the postal service has a regular routes for small trucks, large trucks, planes, boats, and so on, and to move the letters between the postal service sites. So the service must be able to receive and forward the letters, and it must make good decision about where to send each letter next. So you understand how like it works. So still thinking about the postal service is the difference between the person sending the letter and the work that the postal service does. The person sending the letter expects that the postal service will deliver the letter most of the time. However, the person sending the letter does not know the details of exactly what path the letter takes, like how what are the path it's how the letter is going to go. So in contrast, the postal service does not create the letter, but it accepts the letter from the customer. Then the postal service must know the details about the address and postal groups that into larger groups, and must have the ability to deliver the letter. So the TCP IP application and transport layer, so it acts like the person sending letters through the postal service. The upper layer works the same way regarding of whether the endpoint host computers are on the same LAN or are separated by the entire internet. To send a message, the upper layer asks the layer below them, the network layer, to deliver the message. So the lower layers of the TCP IP model acts more like the postal service to deliver those messages to the correct destination. Okay, so so what does this all matter to networking is like, if you take the TCP IP networking model, the internet protocol works just like the postal service. So IP defines each host computer should have a different IP address, just as the postal service defines addressing that allows unique addresses for each house, apartment, and houses. Similarly, IP defines the process of routing so that the devices called routers can work like the post office. So you can compare the post office to a router which is forwarding packets of data so that they are delivered to the correct destination. So just as the postal service created the necessary infrastructure to deliver a letter, the post office's writing machines, trucks, the planes, and the personal network layer has to define have a network architecture should be created so that the network can deliver or to all the computers in the network. So the internet protocol addressing basics. So like if you just check about the basics, like so IP defines addresses for several important aspects. So you see here the IP addresses of things. So just to say that if you take the web server over here, like just for example of how the web server has an IP address, any like you configure, you take this as a web server. So what happens here is so the web server Larry and the web server browser Bob, they, instead of ignoring the network between these two computers part of the infrastructure, so what happens here is so each IP address, like so you see this is like we are just defining some set of IP address over here. So each IP address will have four numbers separated by periods. So like in this case, so Larry, you just take an example, he uses an IP address 1.1.1 and this guy uses an IP address 2.2.2. So this style of number is called a dotted decimal notation. So like it's a, like IP addresses begins with one must be on the upper left, like you can say that. So routers, like what are routers? Routers are networking devices that connect the part of the TCP IP network together for the purpose of routing. So IP packet to the correct destination. Router do equivalent of the work done by each post office site. So they receive the IP packets on various physical interfaces and make decisions based on the IP addresses included with the packet, and then physically forward the packet out to some other network interface. So that's what the router does. So like if you take in this case if you see like a step-by-step basis, what happens here is like so Larry wants to send an IP address, so IP packet. So Larry's IP process should choose to send the packet to some router. So Larry, this guy should send his packet to some routers, a nearby router on the same LAN, with the expectation that the router will now know how to forward the packet. So on this step 2, what happens is like the router receives the IP packet. So on the step 2, like you see here, the router 2 receives the IP packet, and the IP process makes a decision. So the first router R1 looks at the destination address. So the destination address is 2.2.2. So it compares that address to its known IP routes and chooses to forward to router number 2. So this process of forwarding the packet is called IP routing. So what happens in step 3 is the router to the next router also repeats the same kind of logic which is used by this router 1 and 2. So IP process will compare the packet's destination IP address and make a choice to forward the packet to the right one. So so what are this TCP IP data link and physical layer? So the TCP IP's models data link and physical layer, they are the protocols and hardware required to deliver the data across some physical network. So the two work together quite closely. In fact, some standards has been defined for focusing on the data link layer. Just so each layer in a networking model. So the TCP IP data link layer provides services to the layer in the model when a host or a router IP process chooses to send an IP packet to another host. So each layer provides a service to a layer above it. That's as simple as that. So to think about it, like how this guy sent his packet to this guy. So what are the process involved from router to router? How it chose the okay, this is the router the address that it needs to. Then it started to forward. So that was a process here. So what happens here is goes as a process. So it happened as a process, like how this packet has been forwarded. So it was steps. So that is so this guy, he encapsulates the IP packet in the Ethernet header and creates a frame, and then second step, like uses some electricity as an Ethernet cabling. So just as an Ethernet header is that there should be a physical cabling or Ethernet cabling, and the router R1 should receive this electrical signal over a cable. There should be a medium of transmission. So and recreates the same bits as electrical signal. So the router R1, again, what it does, it's going to encapsulate the IP packet from the Ethernet frame, removing and discarding the Ethernet header and the trailer. So that's how the flow is going to happen. So again, like so when it comes to the data encapsulation, so we have to create and encapsulate the application data with any required application. So example, the HTTP says okay message can be written in a HTTP header. So encapsulate the data on the application layer. So we have to make sure the IP, the address is defined on the computer. The layer uses both the header and the trail. Okay, so the reason is, like, when talking when we think about this networking, about the segment packets and this frames. The TCP data as a segment, the IP data as a packet, and the frames that are sent as a packet. So at one point, like when you think about the history of the OSI model, like many people think that OSI model would win the battle of the networking discussed earlier. So but instead of running the TCP IP on every computer in the world, the computers would be running with OSI. But however, the OSI, like it actually didn't win the battle. So in a longer process, if you say instead of TCP IP, some of the original protocols, so why is has been used, still exists. It's still the OSI is still being exists. So during these years, many people like thought like OSI model would become like a common place in the world of networking. So comparing with the OSI and the TCP IP, so these are the OSI layers, like so PD, NT, SP, physical layer, data link layer, network layer, transport session, presentation, application. Here in the TCP, you have the physical, data link, network, transport, and the application. So like in the TCP model is in use today. So in the right you see the TCP, on the left you see the OSI model. So they uses the exact same layer as OSI at the lower layer. The functions generally match as well for the purpose of discussing networking, even though the world uses TCP IP today rather than the OSI. Like we tend to use the numbering from the OSI layer. For instance, when referring to an application layer in a TCP IP network, the world still refers to as a layer 7 protocol. Also, while TCP IP includes more functions at its application layer, the OSI breaks those into a session, presentation, application. So most of the time no one cares about the distinction. So you will be seeing like layer 5 to 7 protocol. So like TCP IP, each OSI layer so asks for services for the next lower layer to provide the services for each layer. So OSI uses a more generic term in refer to messages than the frame, packet, and segment. So your OSI uses the term packet data unit, PDU. So a PDU represents the bits that includes the header and trailer from the layer. So this is the whole concept, guys, about this TCP IP architecture. Hope this video was useful. Cheers, guys.